So most recently we looked at prime factorization, and I told you that we would be able to use that to help us find least common multiple and greatest common factor. So we're going to move into least common multiple, but I am going to show you some other methods to finding least common multiple. Prime factorization is not the only way, but it is one way. And sometimes you need more than one way because it doesn't always work. It's not, or one method might be better in one situation than the other. So we're going to look at least common multiple today. So our learning target, I can define and find the least common multiple. Well, first of all, we need to define what a multiple is. And it is the result of multiplying a number by an integer, which basically means a whole number, whether positive or negative, just not a fraction. So we're talking about numbers that do not have decimals or fractions. The result of multiplying a number by an integer. So looking at that as an example, let's say that I wanted to find the multiples. Yep. I wanted to find the multiples of 3. Well, on my number line, here's 3. And I can say, well, the multiples of 3, 3 times 1 is 3, so that's one multiple. 3 times 2, or adding another 3, is 6, so there's a multiple. The next multiple is 9, then 12, then 15, then 18. And does it stop there? My number line stops, but does that stop the multiples? Think about that for a second. Do I ever stop finding multiples? Well, the answer to that is no, hopefully you've established. They are infinite because I can keep counting by threes forever. It never stops. So I do want you to think of multiples as being infinite, never ending. There are lots of multiples. Okay? And basically what you're doing here is you are skip counting by threes on this case. 3, 6, 9, 12, 15, 18, 21, 24. Okay? That's all we're doing. Those are the multiples. Now that's not the least common multiple. That's just the multiples of 3. Or the multiples of 4. 4, 8, 12, 16, 20, 24, 28, and so on. We're just counting by 4s. Those are our multiples. So let's try multiples of 9. Well, I want you to see this as two different ways. One, let's just think about adding 9 over and over again. So 9 plus 0, or not 9 plus 0, excuse me. There's 9 plus another 9 is 18, plus another 9 is 27, plus another 9 is 36, another one is 45, 54, 63, dot, dot, dot. That can go on forever. But look at these things that I'm calling my multiples. Remember, these are infinite. Look at these. These look like the answers to multiplication problems when we did our multiplication tables for 9s, because 9 times 1 is 9. 9 times 2 is 18. 9 times 3 is 27. So you could also think of multiples as the product of a multiplication. So if I did something like 9 times 11, 99, that means 99 is a multiple of 9. So we're just all of these different things. If I kept counting by 9, those are our multiples. Okay, which brings us to the least common multiple then. It's the smallest multiple that 2 or more numbers have in common. Smallest multiple that 2 or more numbers have in common. So we'll take 2 numbers and you'll skip count them, make a list, and then what's the smallest one that they have in common? So let's try the LCM of 6 and 11. So 6, we're going to do the multiples here. Well, 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. 6 times 4, 24. 6 times 5, 30. 6 times 6, 36. 6 times 7 is 42. And we're going to stop because let's see if any of these match. Multiples of 11. 11, I'm just going to count by 11s. 22, 33, 44, 5, 66, 77. None of these match up yet, do they? So I'm going to go back up here. I'm going to keep adding 6. 48, 54, 60, 66. Oh, wait a second. I have a common multiple. And it's the smallest common multiple. So the LCM of 6 and 11 equals 66. That's finding LCM using a list. All I did was start listing them out, every multiple, until I came up with this. This is using your multiplication tables or using repeated addition. And you're just making a list. And there's nothing wrong with making a list. This method will work every single time if you keep up with what you're adding or keep up with what you're multiplying. But sometimes your list could get really long because it may be a while before you come up with that least common multiple, before you find that matching number. So you might need to use a different method. So let's try using prime factors. Finding least common multiple using prime factors. Let's find the least common multiple of 8 and 12. So going back to what we learned the last lesson, break down the 8. 2 times 4, prime, also prime. So this is 2 times 2 times 2. Over here at the 12, 6 and 2, prime, 3 and 2, prime, prime, 2 times 2 times 3. And this is where I make a Venn diagram. Here's the 8, and here's the 12. Okay, so I look and I go, okay, do they have any common primes? Not common multiples. Do they have any common primes? And I look and I go, look, I see a 2 here and a 2 here. So since it's in common, I'm going to write it once right there in the middle. There's a 2 and there's a 2. So there's another 2 in the middle in common. There's a 2 here, but not another one over here. So this 2 is going to go here. There's a 3 here, and it's not over here. So it's going to go here, because it's special for the 12. Now to find the least common multiple, I'm just going to multiply all of these numbers that are in my Venn diagram. So 2 times 2 times 2 times 3. 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. So the LCM is 24. So that's one method. You can use prime factors. Notice what I did. I just took what they had in common, it went in the middle of the Venn. I took what was unique, and it goes under each number, and then I took all of those and I multiplied. Okay? You can use that method. Or I have one that is called the birthday cake method. So let's try it. Okay? Also known as the ladder as well. Now this one, you will write an upside down division, it looks like. Okay. Looks like I'm doing division, but I'm doing it upside down. And then over here to the side, I'm going to think, what can I divide 20 and 24 by? And it really doesn't matter. Just take your pick. Pick something. All right, well, I know 2. Okay, 20 divided by 2 is 10. 24 divided by 2 is 12. Can you still divide 10 and 12? Yep, I can take that further. So I can do 2 again. 10 divided by 2 is 5. 12 divided by 2 is 6. And now I look and I say, well, can I go any further? Nothing will divide 5 and 6 except for 1, so I'm done. And then to find the LCM using this, what I'll do is I'll take all of the numbers down the side and the last row of numbers at the bottom, and I'm going to multiply them. Make an L right here. 2 times 2 is 5 times 6. 2 times 2 is 4. 5 times 6 is 30. And 4 times 30 is 120. So the correct answer is LCM is 120. The LCM of 30 and 24. I'm going to do the method, I'm going to do the prime factorization and the birthday cake. So prime factors, factor tree. This is 10 and 3, 5 and 2. 2 times 3 times 5. This is 6 and 4, 2 and 2, prime. 2 and 3, prime. 2 times 2 times 2 times 3. Okay? Make my VIN. Here's for 30, 24. Okay. I see a 2 and a 2. Those are in common. I see a 3 and a 3 in common. A 5, no 5, it goes here. A 2, no more 2s over here, no more 2s. Another 2. Now multiply. So 2 times 2 times 2 times 3 times 5. 2 times 2 is 4. Times 2 is 8. Times 3 is 24. And 24 times 5 is 120. It's the same LCM, isn't it? That's okay. Now let's try it if I use the birthday cake method. Let's see, I look at this. You know what? I think I can divide that by 6. I could have used 2. I could have used 3. Take your pick. It doesn't matter. As long as it will divide both numbers. 30 divided by 6 is 5. 24 divided by 6 is 4. You know what? Actually, I can't go any further. Nothing will divide 5 and 4 except for 1. So just like I said, we will take all of these and multiply them. 6 times 5 times 4. 6 times 5 is 30. Times 4 is 120. So you notice that I did get the exact same answer regardless of the method that I used. Alright, your turn. 2 questions. I want you to find the LCM of 10 and 12 and also find the LCM of 12 and 16. You take your pick. Do you want to use a list method? List out all the multiples? No problem. Do you want to use prime factorization? Use a factor tree? Not a problem. Do you want to use the ladder or the birthday cake method? Go for it. Do you want to use a mixture of them so that you practice both of them? Do that as well. You pick which one works best for you, and I will see you in class.